Hi everyone, we should be live now, so welcome to our webinar. See that people are joining us. So let me introduce myself. My name is Platon. I'm a marketing manager here at Xinnor. And on the right side here, you can see the chat. So please say hi and tell us if you can see and hear us well.
I can definitely hear you, Platon.
Yeah, that's great.
Come on, people, don't be shy. Write in the chat if you can hear us properly, and then we can get started. Okay.
Okay.
People.
I see that it's fine. So, all right, let's start. And let me give the floor to Davide, our CRO, who will tell you about our plan for today and introduce the speakers. So, Davide.
Thank you, Platon, and welcome everybody. Today we are going to talk about how to implement xiRAID in high availability. Before doing that, I will give a quick introduction about the company and about xiRAID itself and why we need high availability. And then Alexey will take us to the clusterization approach for high availability, how we use a pacemaker agent, and the challenges that come with implementing high availability. And then it will drive us through xiRAID 4.1 with cluster support enabled. And we will close with Daniel, who will give us a live demo of xiRAID in high availability. I will give some tips in terms of possible hardware requirements, and then we can close with a Q&A. So if you have any question, write them into the chat, and we will answer at the end of the presentation. So the speakers for today, beside myself, we have Daniel, our solution architect based in Israel, and we have Alexey, our engineering manager based in Tbilisi, Georgia. Few words about Xinnor. Xinnor is a startup company based out of Israel. We were founded 2 years ago, but in reality, we are much older than that. So our heritage is going back more than 10 years because we inherited all the international rights on the intellectual properties of a company that used to be called Radix. Our mission is to develop the fastest RAID engine in the market. So we're about 40 people, most of them in development, very talented people. And we already have a sizable business. We already have more than 100 petabytes of data that are RAID protected with our software. We partner with major players in the SSD space like Western Digital and Kioxia, as well as a very well-known company like NVIDIA and a software company like BGFS and others. And last year at Flash Memory Summit, we have been awarded the Best of Show for a customer implementation we did with Western Digital and BGFS. So a few words about our main product. Our main product is called xiRAID. xiRAID is a software RAID which combines two key technologies. From one side is the way we leverage the AVX instruction on the x86 CPU, and we combine it with our lockless data path. What does it mean? It means that we have a way to dynamically allocate the stripe to the core, to the available CPU core. And by doing that, we can evenly distribute the load across all the available cores without creating any spike of load, which ultimately would translate in bottleneck in the performance. So those are our secret sauce. And with those, we are able to deliver the best performance in the market, as we demonstrated just recently at the supercomputing event in Denver. So we claim that by implementing RAID 5 and RAID 6, we can deliver up to 97% of the raw NVMe performance. And performance are critical in normal operation, but even more in degraded mode when one drive is taken out of one or more drives are taken out of the RAID. In this case, our performance stays within 70 to 80% of the normal operation performance, which stands us apart from any competitor in the market. The software is very flexible. We can have on a 64 RAID, you can have as many number of drives to create the RAID. We support any RAID level. We also support erasure coding M+M with up to 32 drives for parity. And you can have unlimited number of RAID per installation. We are software only, no need for a PCIe card, no need for a GPU, no need for any extra hardware, because we very efficiently use the system resources. And we also have a technology to handle network instability that enable us to create a RAID on local drives, but also on network attached drives. So today we are going to show you how we are leveraging a pacemaker to create a high availability. But let's explain why we need high availability. So from one side, we need RAID. Is the RAID still relevant for NVMe? The answer is yes, because even though NVMe are more reliable than spindles, than rotating media, they can also fail. So if there is a company called RFs that is tracking the failure that they register in their data center, and they publish a quarterly report. So you can look at their report. They claim 0.36% annualized failure rate. So NVMe can fail, but then when you implement NVMe on a single server without protection on the server, there are many other components that can fail. And if you have a drive failure, you can protect it with RAID. If you have a system failure, you can protect it now with a high availability implementation. And the protection is not just over losing the data, but it's also about avoiding downtime for the application. Okay, so with this, let me hand it over to Alexey. Alexey?
Thanks, Davide. And I also join greeting everyone here on this webinar. Nice to have you. And so let's take a look how high availability cluster can help us to mitigate those challenges about data availability. And in general, clusters do it by introducing two major things into the picture, which are redundancy in the form that we split the load of resource processing and service between multiple nodes in the cluster, and distributing the data between those nodes so that we also can have multiple copies of the data we want to keep available. Additionally, cluster approach is nice because it brings some other benefits which are not specifically related to the data availability, but are very important for building real end-to-end business solution, such as scalability and load balancing. So when we started to think about how we can fit our xiRAID into the cluster, we decided to choose the pacemaker-based high availability cluster because since the beginning of the millennium, it established its way as a standard de facto for building the cluster solution. It is open sourced, and it is actually very well supported and maintained. There is a dedicated company named ClusterOps that keeps in custody the sources, and all major Linux providers are actually contributing to that, not to mention some other contributors from the particular systems, such as databases, etc., etc. So we decided to explore this, and this is what we come with. So for the pacemaker cluster, it's just 4 major components which require to build one. The pacemaker engine is actually what the whole solution gets the name from, is a global resource orchestration engine. There are 2 types of agents. Resource agents are responsible for individual resource management on each node, and fencing agents make sure that during the failover, the cluster is kept in consistency. And finally, corosync is a component responsible for cluster node synchronization. It is not specifically needed to be corosync as a tool, but pacemaker and corosync are coming from the same source repository and maintained in tandem, so it's a natural choice, and we also are using it in this tandem. So in general, in this cluster, everything is represented as a resource, whether it is an application, whether it is an IP file system, and our basic idea is to add the RAID also as a new type of the resource into the picture. And this makes xiRAID, which is xiRAID touched components are highlighted in green here. So we are introducing our agent and our RAIDs as a resource. We obviously add some software on the nodes, and we are using shared drives configuration for our initial research and testing. So pacemaker makes sure that if any node gets broken at any given moment, the resource, which is replicated on another node, is actually starts up on another node, and this gives smaller time for service interruption than normally might be needed to actually restore the original node. And when the node is restored, the cluster comes back to the normal operation. I see that there are coming questions, and thank you very much for that. We will keep track on those and probably address after the demo during the Q&A. Please keep adding them into the chat. So at the same time, as Davide mentioned, if anything happens with the drive, this is not even this is handled by our software, and it does not lead to any service interruption on the cluster. Even the active node remains the same. xiRAID goes to degraded mode until the disk is replaced, and then restore its normal operations. So any client services or any dependent resources in the cluster will not experience any unavailability, any disconnection from the resource. But at the same time, being very good and beneficial solution. Clusterization comes with its own natural challenges. And for us, two main things are interesting and important here: split brain and amnesia. The split brain comes from the fact that there is no real possibility for individual node to understand and distinguish between two different situations. The situation number one is when another node actually fails to operate, and the situation number two is when the connection between two nodes is lost. So in this case, it is not the problem here is that the cluster cannot make the decision which node should continue to run the resource, or maybe everything should be shut down. And two common approaches to mitigate this challenge are quorum and fencing. And quorum is a reliable and simple way of making the decisions based on the majority, but requires multiple nodes to utilize. While fencing can be applied for two-node configuration, which is very common for storage systems, but requires some additional complexity in your cluster, such as fencing agents and sometimes some additional hardware network connections in other systems. So the second one is amnesia, and amnesia is more the problem of the local data, as well as more resource specific, because every resource type usually amnesia problem manifestates slightly different, but in the essence, it is the situation when some local change made by one node does not get propagated in time across the cluster, and then if something happens and then restored, this change becomes forgotten because not propagated during restoration, the state of the data restored from the previous unchanged state. And in order to mitigate amnesia, usually more resource type specific things are required. And in our case, because we are talking about RAIDs, for RAIDs, the data which is vulnerable for amnesia is RAID configuration, which is local for the RAID software instance. And typical approach to deal with it is to add more intelligence to replication of the configuration files across the cluster, as well as adding the redundancy in terms of how many copies we have. And we will get to that very soon. So let's actually look what the next version of xiRAID has to actually implement all this. xiRAID 4.1 is in an upcoming release, which is currently coming through the final testing. And in general, we are targeting something like the cluster configuration, which is shown on this picture, where you see schematically two nodes as a dash outer boxes. In each node, green boxes represent the resource agents. The purple boxes are actual resources, how cluster sees them, and they are boxed to highlight that cluster can configure resources to be affine to each other so that they are always served from the same node. And finally, the actual RAID and the file system instances mounted on that RAID are also depicted. So let's look into more details into that. So first of all, we implemented xiRAID resource agent, which is a bash script. Essentially, it will be added to xiRAID distribution, and the only thing you would need to to put it into work to link it into the right place for your particular installation of the cluster. We also added a new additional config synchronization method through utilizing a third-party tool, which is called xiSync². This is the tool for reliable file replication, and it is invoked for each change of the configuration on the node, so that the change gets propagated to another node. But additionally, it can be configured, and Danny will show that, to run every minute, so that so to guarantee that there will be multiple attempts to deliver the change. As well, the configuration data have been placed on each of the RAID drives themselves to be used during the RAID recovery. So typically for the RAID containing 8 drives, for each node there will be 9 copies of the config file. We also redesigned config files themselves. We removed some information which was not actually a configuration information and took it out. We separated one large config for xiRAID installation into the set of per RAID configs, so and they are replicated independently. We also added the integrity data to each configuration file, such as timestamps and checksums, to make sure we can validate the replicas during the restore procedure. And finally, xiRAID recovery procedure now becomes much more intelligent, because it uses multiple copies. It gets from different sources, validates them with integrity data, and finally, only after it picks up the most up-to-date and valid configuration file, it initiates RAID restore process. So in a nutshell, that's all for my part. And of course, it is much better to see how things work in live than just hear about it. So I'm pleased to pass the screen to Daniel.
Thank you very much, Alexey. Thank you. So let me describe our demo setup, and I think in the same time I will try to answer some questions what I see in the chat. So for the demonstration here, we have a quite simple configuration. We have 2 virtual hosts installed with Linux, and these hosts share the same set of drives. So it is a representation of some hardware configurations with dual ported drives, like SBB systems, where you have multiple NVMe's in one box with 2 servers embedded, and each drive has connections to each server. Or, for example, SAS SSDs connected to 2 hosts, or eBOF drives from eBOF connected by NVMe off to 2 drives. So all of these configurations are valid, because yeah, our goal in xiRAID 4.1 was to allow our users to create their own clusters with xiRAID. We don't provide the specific xiRAID configuration. We provide agent allowing to create the configurations. So we have these nodes, we have shared drives, we have some pre-configurations done. Both nodes are listed at each other hosts. To allow them to be resolved, we have time synchronized, we have a better version of xiRAID 4.1 installed on both nodes. We have the sync square installed and configured on xiRAID to replicate the configuration changes, as Alexey said. So we have configure replications by scheduler, and we also have asynchronous configuration replication activation in case of the configuration change on one of the nodes. How to configure the sync square and how to all these other things to do will be described in the xiRAID 4.1 documentation. Yes, Peter, it is correct. The shared drives are shared, it's mostly not Gboard, but mostly, I think now we mostly rate it on SBB systems. Davide will tell about this later after my part. So yes, it should be at the drives shared at hardware level or at level of a SAN with eBOF or something like that. So, and yes, we also have a pacemaker cluster configured here with Stonith. Since we work with the shared storage, that Stonith is required, because without Stonith, most probably you will have, it's not my slide.
Yeah,
because without Stonith, we may have, Davide?
No, I suggest we go through the demo, otherwise we might be late on time. Some of
Okay, I will switch now to the demonstration. Let's go to the scenario. The scenario is RAID creation. We will create resources for these RAIDs. We will create a file system resources over this RAID just to show you how we can combine the RAID resources with other resources. We will check the failover demonstration and configure change replication demonstration. So let me start share my screen. So do you see my screen?
Yeah, we can see it.
Yeah, great. So what you see here two SSH sessions to two hosts. The host 1 is node 1, the host 2 is node 2. They are running cluster with fencing running. And we also have the same set of drives here. One of the important things we have to do after the xiRAID installation to work with cluster, we should say xiRAID not to run, not to start RAIDs which are in the xiRAID configuration after the host reboot. So this is the settings we need to set. We already have copied, linked our file pacemaker agent to the proper directory, so everything is fine, and we can continue with the RAID creation. We will create both RAIDs on the same node for the time of the configuration in this example. So we create a standard xiRAID RAID with level 5, stripe size 128. The name of the RAID will be R5-1. It will consist of 4 drives: SDB, SDC, SDD, and SDE. So the RAID is running and initializing on the second node. We also have this RAID but it is unloaded, but the configuration was already replicated to the second node. Now let's create the second RAID. It will be about the same. It will a little bit differ in the strip size, but it doesn't matter, and its name will be R5-2. Sorry, most probably I have not cleaned up it fully after yesterday. Experiments. So, yeah. We have two RAIDs on the first node, and we have two RAIDs on the second node, not loaded, but this node already knows about both of the RAIDs. Now let's create the file systems, because we will work with the file systems on these RAIDs. We'll format it. So if you don't know, the xiRAID RAIDs are represented in the Linux operating system as a block devices, which starts with the dev z and then the RAID name. So we format these devices. And what also we need to prepare on both nodes, we need to create the mount points where the file system will be mounted by the cluster. And these mount points will have to be created on both nodes. So we are ready for creating a cluster configuration. Usually it is much more useful to create a cluster information base copy, upload all the required changes to this copy, and only after that upload all the batch of the changes to the running cluster configuration. So let's create the cluster information base copy. I'm not sure if I removed the last one, so just to be sure that I have an empty file. So okay, and now we will start with the xiRAID resources creation. To create a resource, I need to know the RAIDs names and RAIDs UID. The RAIDs names I know, RAIDs UID can be get from the RAID configuration. I'm asking the system to show me the RAID configuration, single RAID configuration in pretty JSON format, and I will extract the UID field from that. And the same operation for the second RAID. Okay, now let's create the resource for the first RAID. What this command includes? So it is PCS, it is a cluster management command for pacemaker. We say that the configuration have to be saved to this file instead of to be run online on the running copy of the zib. We create resource. The resource name will be the same as the RAID name. Here is the name of the resource agent which will be used. The name of the this is the name of the RAID. This is UID of the RAID and some of the parameters of timeout, standard time parameters. All these commands will be, I think, described at our documentation for xiRAID 4.1. Yeah, and now let's repeat. Let's create a resource for the second RAID. we are inserting the UUID. So it is absolutely the same command. We just use another resource name, we use another RAID name, but for sure the resource agent name is the same because this is the resource of the same type. Now I would like to run these RAIDs active in a cluster on different nodes. I would like to R5.1 by default to be started on node 1 and RAID R5.2 to be run on the node 2. So to do this, I will set up a couple of constraints, setting the resource node running preferences with weights. So I say that resource R5.1 prefers to be run on node 1 with some weight. It is for more this number is for more complex cluster logic, which we will consider here. And the second cluster node, so the second RAID R5/2 resource prefers the node 2 to be started on. After that, let's create resources for the file systems. So we are here is a command for the resource creation. We create resource of the file system. The agent is file system. The name of the resource will be file system 1. And here the parameters are different. We say that this file system requires this device. This is the device of the RAID 5-1 RAID. And we also set the directory where it should be mounted and the file system type. So the full name of the agent is of the cluster agent of the file system. And but now cluster knows nothing about dependencies between these two RAIDs. We know that this file system, since it wants to mount the file system which was created on the RAID, for sure it should be started on the same node where the RAID is started. By default, the RAID have to be started on node 1, but in case of failover, it have to be started on 2. It will be started. So we need to say that these resources have to be co-located on the same node. To do so, we define a constraint which says that these resources have to be started on the same node. And we also have to say to the cluster that a file system resource have to be started after startup of the RAID resource, because in other case, cluster may try to mount the file system even before the RAID will be active and the device will be available. So this constraint says that R5.1, that FS1 have to be started only after R5.1 start. Now we set these parameters for the first RAID and the first file system resource. Now let's repeat it with the let's create the second resource, second mount point, and set the same parameters to it. We are creating the file system 2 resource, setting the
Did we lose Daniel?
Yeah, I think we lost him. So
Oh.
what I suggest while we're waiting for reconnecting, why don't we go through the Q&A in the meantime?
Yes, let's do. And I can probably take some of those questions from the top. So the first one was for shared drive is an NFS file. I don't think this is how we're supposed it to work. It's more about the same visibility for the drives on the same on different nodes. Daniel can probably speak in more details about technical aspects of this, but in general, we are currently considering we are testing on the configurations which are using storage bridge base. As he already mentioned, we are also assuming that there should be no specific restrictions to use EBOFs or internet connected NVMe's, but we have no final testing results for this. So for I hope this answers the questions about shared drive configurations for now. Can we have more than 2 nodes in the cluster? Yes, we can. At least xiRAID does not have any specific restrictions from that. Once again, for us, it is probably more the question about the time we need to test and confirm. But we would be very glad if someone could test it as well. And we already are doing some early access program, even for 4.1. With a couple of partners, and if you are interested in participating, please let Davide know, and he will connect you with the team, and we will build some early access bundle for you. So quorum devices for judgment against splitbrain. This is a very good question, and yes, definitely this is possible. But for us as a software RAID vendor, we probably cannot assume that we will have additional nodes, because essentially additional device is still equivalent to have some additional node. So yes, it is technically possible, and xiRAID probably have nothing to do with it. So if you have it in your configuration, also please try to test it and let us know how it works. I see Daniel returned. Daniel, welcome back.
Yeah. Thank you. Sorry,
yeah.
sorry for the breaking. So,
it's okay.
Yeah. We finished at the moment where we created the second file system resource. Now let's set up the.
You will need to restart sharing.
I haven't started. Sorry.
Yeah.
Now we can see it.
Yeah. Okay. Great. So now we create the collocation constraint for the RAID 5.2 and file system 2 resources, and then creating the order constraint of the resource order start. So basically, the configuration is ready. We defined 4 resources, 2 resources for the RAID, 2 resources for the file system. We set the correct sequence and collocation rules, so everything is fine. Basically, we are ready to apply the configuration, but before of that, I would like to unload the RAIDs. RAID show. Basically, RAID we have no RAIDs loaded here. We have no RAIDs loaded here. We have here only the system drive mounted. We have here only the system drive mounted. Now, so let's now apply the RAID configuration we created by this command. So let's start. Let's check what happened. Now we have the resources we configured: RAID 5.1, RAID 5.2, and the file system. So we have RAID 5.1 running on the node 1 and file system 1 running on the node. Let's check. We have the mount point mounted, and we have the first RAID loaded on the first node. Now let's check here. Here we have only the second RAID loaded, and we have the file system mounted. So let's see how the system will, what will be the system behavior in case of the node of a node failure. By this command, I will hardly reboot this node, the node number 2. So the node is not available. We see that the cluster logic can't understand at this moment what's going on with the resource 5.2 and file system 2, because they was started on the node 2, which is not available now. After that, basically, it have to decide that it is not available, run stoneth for the node 2, and then run the resources on itself. Basically, we have it here. We have both RAIDs running here, and both of them are mounted here. The initting here is our red hole technique protection, because the RAID was not, the RAID 5.2 was not cleanly unmounted on the node 2. Then during the RAID activation, we are running our red hole protection check. So this is our red hole protection check. It is normal. So what we can do now, let's check what will happen if I will change the configuration of the RAID. For example, as you understand, the node, when the node 2 was crashed, it had this configuration, current configuration of the RAID 5.2. Now, while this node is not available, I would like to change this configuration by replacing one of the drives. I replaced drive number 2 with drive dev SDN. So we have the new drive here, and reconstruction is going. The second node is up, but the software, cluster software is not running here, because basically it is, from my point of view, it is not an idea to run cluster software automatically, because in case of a failure, if cluster software will run automatically, the cluster most probably will automatically move the resources to the failed node, while you basically need to have some time while cluster is not running by the reason of the failure. But we know the reason of the failure in this particular case, so we create this failure by ourselves. So let's start the cluster software on the second node. we see that cluster software started, and the cluster started moving the resources which have to run on the second node to the second node. The resource moving is finished successfully. And we see that the RAID configuration is actual. We did not lose the configuration change during the failover. So I think at this stage I will finish the demonstration. Thank you very much, Alexey, Davide.
Okay, thank you, Daniel. Thank you for all this in-depth demonstration. There are many questions on the chat, and some of them are related to the possible hardware configuration that can be used with our HA implementation. So let me share one last slide that show you some of the possible hardware configuration that we see in the market. So there are multiple options. From one side, there are dual nodes server which share NVMe. We're talking about NVMe. In reality, our software can handle SATA and SAS interfaces as well. But where we really show a big advantage in terms of performance, where since we focus on performance, we focus mostly on speeding up and protecting NVMe installation. So there are options from Viking, Celestica, ASC. Supermicro is coming out with a new dual node server that will be available in a couple of months. EcoStream from the US, they also have a similar server. And we see that Viking is planning to release by the summer also denser solution, one with 32 drives and one with 56 NVMe drive in a single 2U box with 2 servers. The alternative option is to use a commodity standard x86 server without any NVMe drives connected to eBOF. And here you see the representation of 3 Ethernet attached boxes from Viking, from Western Digital, and from Ingrasys. As Alexey said, for now we are not maintaining an approved vendor list because we are a software company and it's hard for us to do compatibility list. But we are actively working with Viking. We're actively working with Western Digital to validate the solution. So hopefully we will be able to share in some public document pretty soon the results of those validations. With this, I think we can move to the Q&A session. Some of the questions were already addressed by Alexey, and I suggest that we go through the list of what is still to be answered. So let's start from the top.
Okay, so
yeah, go ahead.
Yeah, I think that we started the question about quorum, but I think that I answered that. And so
following question is, does it work with a hardware RAID? If both the nodes is already configured with the hardware RAID, can we configure this on top of that as double protection? Don't use hardware RAID. Don't use it.
I think I have answered this in written already. Yes, I mean, typically, in order to bring any new type of resources, including any new type of the RAID, you will need its specific resource agent at least. And as I just spoke, we had to change the RAID itself in order to nicely fit into the clustering. So you will also need to make sure that the hardware RAID solution you're looking at also provides something like configuration replication, etc., etc. So in general, we did not try to put our RAID on top of other RAID. And I wouldn't. Go ahead, then.
Yeah. I had one more point, because I can't imagine where you have a hardware RAID. And basically, where you have the hardware RAID, if you have a hardware RAID which is created within an RAID adapter installed on your server, then how you will switch the configuration? If you have created a hardware RAID on a disk array and you transfer the LAN created on the RAID by a SAN, in this case, you just don't need additional tools, additional xiRAID agent to make clustering with such LAN, because basically the classical high availability dual node or multiple node cluster configuration is for a shared SAN shared LANs, so you don't need here.
Yeah. And by the way, it's not a great practice to use hardware RAID on NVMe, because you are limiting the performance. With hardware RAID, you only have 16 PCIe lanes, so you cannot get more than 4 drives performance. That's why we exist. Then the following question is about replication of configuration changes is handled automatically by xiRAID, or admin should manually sync?
The quick answer is yes. It's exactly why we did it. So we can probably move on to the next one.
No. I just want to say that basically it was what we showed in the demonstration. And most of the changes done within version 4.1 to support the clustering was done to make possible the configuration replication.
Exactly this.
Yeah. Okay. I want to make sure we answer all the questions, so we only have 2 more minutes. Shared drives is a shared JBOD connected to 2 nodes. Yeah, we answered this question already. So for NVMe, we need eBOF, not JBOD, or a SBB platform. So 2 nodes connected to shared drives. For SAT and SAS, yeah, it can be a JBOD.
And you can't use SATA. They are just single port devices.
You're right. Sorry, my bad. Okay. Following question. So we can use these only for application or data mount and not for the OS, right?
Yes.
Well, yeah, because operation system in this case is probably more the part of the container node and not the resource.
Yeah, I even can imagine the situation when you need to make a system drive which may move from the system in some situation and leave it without a system drive.
Yes. Well, so essentially, if you fail the OS in the cluster, you fail the whole node.
Yeah. Okay. Let's move on. Question from Giorgio: is the monitor interval to be set at 5 seconds, or other values are allowed?
Well, we tested with these settings, but I believe that the other settings can be. Well, if you will send us this question to email with more information, I think we will be able to provide you more specific answer.
Okay.
And if I understand it right, this kind of values are the subject of the fine-tuning each particular cluster. So definitely that's why this is a parameter, and it might be different in your particular setup. And yes, as Danny said, if something goes wrong with different value, we would be happy to jump in and investigate it together.
Yeah. Then a question from Ulash. The drive in the share mode, they will be readable only one node at a time, and other path will be ready only on second node. Is it right?
I think I have answered that in written as well. Typically, we are considering the mode when each particular RAID is exposed as an active resource in the cluster only in one node. And on the rest of the nodes, there will be stale copies with replicated configuration ready to start up in case of the failover. But it also means that we can have multiple, for different RAIDs, we can have active instances of the RAID resource on different nodes. I hope it addresses.
As I understood, the question was about the drives, not about the RAIDs.
Yeah.
And basically, on physical level, on level of NVMe protocol, all devices have to be can be written or written from all the nodes of the cluster. It looks unsafe, but we have no block level transfer protocol, which may, in some situation, block the writing somewhere. And if it exists, if for example, if you will imagine that it exists, then if a node, when the RAID was active, will fail, then other nodes will not be able to get the right for writing on these drives back. So yes, they will. All the drives have to have. All the drives should be available to reading and writing from all the nodes.
Yeah, thank you, Dan.
Following question. Following question from Sami: how the performance of the RAID stacks are evaluated, and how does the CPU load compare to the usual common software RAID solutions?
Davide, do you want to take this over, or do you want me or Daniel?
Yeah, okay. So let me answer the second portion of the question about CPU load. That's one of the main benefits of xiRAID. We tend to, as I described, we tend to share the load across all the available cores within the CPU, and that avoids a spike of load. So if we compare with MD-RAID, you will see that we always consume less CPU in normal operation, and this becomes a dramatic difference in CPU consumption in degraded mode. In degraded mode on MD-RAID, you will see a spike of load on certain core that slow down the rebuild process of the drive and create extra load on the CPU. So in that case, in degraded mode, the difference is even 20x in terms of load. In normal operation, we are always consuming less CPU than software RAID, but also GPU assisted RAID is consuming much more CPU than our software RAID.
I can also add to that this was not the topic of our today conversation, but typically in the upcoming xiRAID 4.1, we are also bringing a new nice feature which helps to specifically allocate the load to manage the particular RAIDs to particular cores in the system. So from now on, there will be more possibility for controlled allocating of the load. So if you have some load sensitive application, you can make sure that the xiRAID software never runs on the particular CPUs and fully allocate that to your application.
Okay, and then to answer the first portion of the question, we actually developed a tutorial on how to perform benchmark and test on RAID. So if you go on our blog, on our webpage, you will see three chapters of the same document where we explain the best practice to run a benchmark by measuring real performance after preconditioning and not just peak performance. Okay, let's move on. Did you consider, question from Peter, did you consider cache sync mirror and further export from the nodes as block devices in AP or AA mode and multipathing? Cache would be needed if extended to use also HDD in standard bus topology.
Yeah, so I would probably take, yeah, it's active passive and versus active active mode.
Let me answer. Our solution is only for NVMe, and we don't use any cache, so we don't need to replicate the cache, and this adds simplicity to our solution. Because when you need to create cache synchronization, it is much more complex when you will build in this engine in a cluster. Sorry, Alexey, maybe you will add something.
No. I think that you answered it absolutely. The main focus for xiRAID is essentially NVMe. We do have some other software which works with spindle drives, which is probably more of the SDS. But today we are speaking about xiRAID, and as Daniel mentioned, because of focusing on NVMe fast drives, xiRAID does not need caching, because in this case it brings more problems than it solves. At the same time, yeah, for multipathing, because there is also this part in the question, we are kind of considering testing it against, but right now we don't have full test statistics yet.
Okay, let's move on. Question from Priyot is about having the slides. Yes, we will follow up after this webinar in the following days, and we'll provide all the material. Question from Rakesh is about the use case. Can it be used for BGFS metadata? Yes.
Yes.
Perfect one.
Let me answer the following questions. I think it will answer for Rakesh. Benefits in the HPC environment. So basically, one of the decisions why we started developing this clustering approach of the xiRAID was that we saw a demand on our solution in high-PC world. We have a very good relationship with ThinkPark, the company which stays behind the BGFS, and we did a lot of tests with BGFS, and some of our partners are doing solutions on BGFS using xiRAID as a RAID for the backend file systems on NVMe. But for now, if they need high availability, in this case, they have to rely on embodied mirroring in BGFS, which really slows down all the write operations in 4 or 5 times. So instead of running body mirroring, where you will need twice more NVMe's, because you will need to have the same amount of data in multiple servers between which you will data. In our solution, you will just need to do a single cluster with a single number of NVMe's. The performance of such solution is very good. I think if you will need, if you have some specific request for the BGFS, we can discuss it and provide you some recommendations. We also know that xiRAID shows quite good performance on when used as a backend RAID for raster file system. And what is much more important, basically, raster file system and BGFS, they both use pacemaker clusters as a foundations for their high availability architectures. Sure, you are not limited only with these solutions, but this is one of the two most useful use cases. We provide quite good performance on sequential, on random. The examples are these.
Yeah,
okay,
and this is exactly the direction we would like to make our further steps about HA. This is exactly the same for our own plans to explore the clustering of the parallel file system, specifically Lustre and BGFS, and how it works all together.
Yeah, and just to conclude on HPC, we are about to release, when I say about, I mean today, we are releasing a paper about the deployment of xiRAID to provide very fast storage to DGX H100. So this is not really HPC, it's more AI, but somehow they are close parents, in close relationship. And so stay tuned, you will see it available on our website in the coming hours, where we showcase that with xiRAID, we are able to saturate the InfiniBand bandwidth, meaning that we can keep DGX H100 busy and not waste time with a very simple and elegant solution. Last question I see is from Rakesh, is about E1.S NVMe disk. We are agnostic to the form factor because we operate the interface. I recall that we had the experience of testing the latest Kioxia PCIe Gen 5 E1, but I don't recall if it was .S or .L. When it comes to available platform, I showed earlier that Viking is about to release one 2U32 base E1.S platform. We didn't test it yet because it's not released, but we are working with them to be able to test it as soon as they make the product available.
Yeah, but we don't expect any problems with the basically form factor, because it is,
yeah,
no matter what form factor is, they are just the PCI devices. These storage, these drives are just the PCI devices.
Correct. Okay, I don't see any more questions. We overrun by 30 minutes, and that's a good sign because we had a lot of questions. If you have more, you have our contacts, or get in touch, and we will be happy to answer your further question or arrange dedicated calls. On the technical documentation, very last question. You will see this document being available on our website later today. If you follow Xinnor on LinkedIn, you will also see that there will be a social post coming out today with the link to the paper. Okay, thank you again.
Thanks everyone for coming. Hopefully it was interesting and useful. Thanks for all your questions.
Thank you. Have a good day.
Thank you.
Bye.
Have a great day.